Hello guys, today I'm going to show you how you can make a Roborace Bot like this for participation in events like Roborace and other off-road based college competitions. As you can see, I'm using here only two L298 motor drivers, but that is part of my plan that I'm going to tell you later in the video. To control the motors, I'm using this Arduino Nano, which is paired with this FlySky FSI6 receiver and this transmitter. Basically, this transmitter gives the signals from the front, back and right left motion, which is received by this unit, which transmits the signals to this Arduino, which then communicates with the two L298 motor drivers to put the current into the motor so that they do the following things. To start off, we need to find a good material as the chassis of the bot, which is both light and strong. Personally, I have used sun mica board, which oftentimes get used in electrical applications. You can also use MDF boards, but that will be quite problematic if the Roborace track consists of water or muddy part, as then the board will perhaps get wet and then you will end up with a very messy situation. And oftentimes I have also seen that many of the teams that come in such competitions use metal chassis. Personally, I would strongly advise against such metal chassis because first of all they are very expensive to buy and they also add to the overall weight of the bot, which can be a problem if there is a weight limit in the competition. Next up, we need to fix the motors to the chassis. As you can see, we are using motor mounts which are made of metal, of course. They are fixed on the board as shown. For the motors, we are using 300 rpm gear 12 volt motors, which are known as Johnson motors in our area. They are fixed using M3 machine screws. You can get these screws in any hardware shop. I also got it from any hardware shop. As for the motors, I would recommend getting the 300 or 400 rpm ones because they provide good initial torque and a decent speed later on. I would strongly suggest to not use the very high rpm Johnson motors because they might look to have very high speeds, but the problem is that when you increase the rpm, the initial torque might not be provided easily by the motors and the motors might stall. So when you are moving from a standstill, the motors might not be able to move the bot, so that can be a problem. Also, as you can see, I have used wires, of course, to solder the motors into their places. Sorry, I mean to say I soldered the wires to the motors, my bad. So well, here is a very important point. If you just use a little bit of solder and then solder it, so that might fall off because such Roborace competitions oftentimes consist of very off-roady type that the motors might get a little bit of shaking and all, so the joints might come off. So when soldering, I would strongly suggest that you use a lot of solder and you heat the terminals up for a relatively long time so that the solder wire gets properly tinned so that the joint is strong, because I have personally been the part of this problem. Next up, we'll be using the wheels. So I have used these standard 8x4mm wheels. These do have a quite a thin profile, but I think that is good for first timers. You can use wheels as per your taste. I also have a bunch of the monster truck type wheels laying around. I can show you. So here you can see I have these kind of wheels. So the wheels are your choice. You can use any sort of wheels as you prefer, and these wheels also play a very important part in whichever type of competitions you are going to participate. For example, if there is a lot of sand, I would strongly advise against using such thin or low profile wheels because they can get easily stuck in the sand. You can instead use the monster truck type wheels which I showed you earlier. Next up, we'll talk about the battery. Usually I have seen that a lot of people use lithium polymer batteries, and of course you must use that kind of batteries only because lithium ion batteries are, first of all, they are quite heavy, and so, and they also, some of the imitation type lithium ion batteries may not also be able to provide the current when you are driving the bot. So I would suggest that you strictly use lithium polymer batteries. Usually I would suggest that you use 3S batteries as 4S batteries may be a bit problematic to these motors. They can burn out if you don't use them carefully enough. So 3S batteries you can get easily. So the prescribed capacity for the batteries in such events is somewhere between 1000 and 3000 milliamp hour. Avoid using very high capacity batteries because they are too heavy and they can make the robot more sluggish. Now we will move forward to the coding. Okay, so here is the code. Here you can see I've added the comments for the pin wirings. Here I have defined the pins, and here the 2 and 3, these are the fly sky pins, and these 4, 5 and 6, 7, 10, 11, 8, 9, these are all the L298 pins. Here I have used the if else if loop to write 4 functions for the front, back, left, right respectively, and here I've used the else to write where all of the outputs are low. This indicates that the motors will have braked, that means they will have stopped. I will also attach the circuit diagram for your kind perusal, and I will also send the code link in the video description. Okay, so now moving on to the part that I told you in the beginning of the video, that the dual L298 solution. So basically this trick was suggested by one of our college seniors. So well, actually, to be very honest, when I started building this robot, I did not have a lot of budget. So well, I followed some tutorials on YouTube, and most of them told me to either use the BTS 7960 motor driver module, as you call it. So well, I actually ordered a bunch of BTS 7960s from a local seller here. So well, when I got them, so they actually came faulty, and then the seller actually denied to replace them. So actually I had a bunch of money wasted on that. So next I saw that you can also use ESCs, but actually the ampere of the ESCs that you need to control such powerful Johnson motors, those ESCs are actually very expensive. So you have ESCs which are expensive, BTS 7960 modules which are actually pretty expensive. So I contacted one of our college seniors and he suggested me to do this trick. So I am going to share this trick with you. So here I am attaching a picture of the dual L298 implementation in working condition. Here you can see that there are two L298s, of course. One L298 controls the front pair of motors, the front two motors, and the back L298 controls the rear pair of motors. So here as you can see that I have used two wires which are red and white in color. I use them to just parallel out the 12 volt and ground output, so that the both the L298s can have a common ground and a common VCC pin, so that the Arduino is actually able to control them. Because if you don't use a common ground, one of the L298s will activate and the other won't because of the common ground problem. And then I used one of the 5 volt outputs of the L298 to feed my Arduino. You don't need to use both because already both of them have a common ground. And then I use the IN1, IN2, IN3, IN4 wires. So 4 wires into 2, 8 wires. The total 8 wires, I fed that into the Arduino Nano and gave the code so that it can power it up. This solution is I mean to say that this solution is especially very useful for those who have a very tight budget and also want to make this sort of Roborace bots, because I would say that frankly a BTS 7960 module might cost somewhere between 300 to 400 rupees, and a L298 it can cost somewhere between 120 to 150 rupees, so that is much cheaper. Also, the reason that I didn't use a single L298 to drive all the 4 motors is because otherwise the L298 would burn out, because when I measured the inrush current of these motors and the running current, they were somewhere between 0.5 and 0.7 amperes. So the L298 it is a 2 amp rated dual channel motor driver. So you can actually imagine that what would happen if the channels have 1.4 amps in each of them, the left and right ones. So actually I tried this and the L298 actually heated up and then it shut down. So that is why this dual L298 solution means that one pair of the L298s gets no more than 0.7 amperes on each channel, so it stays relatively cool. In fact, I use this L298 combination and use this Roborace bot in the track practice day. So well, it actually went on for 6 to 7 minutes and the L298s didn't even heat up very much.